The team worked in small groups to rate both the effort and impact of each idea, designating for both a simple ranking of either low, medium, or high. After the team determined the effort and impact for each idea, they selected the top ideas. These were typically the ideas designated as low effort and high impact. The top ideas were also chosen on the basis that they could be completed during the kaizen event. Afterwards, the team broke up into smaller groups and they all began working to implement their top improvement ideas. The teams made many improvements to the furnace exit conveyor. The chute that allowed billets to go straight from the furnace to the bender was not aligned correctly and was missing mounting bolts. This often caused billets to jam. The team created a new chute design where T-handles were installed to perform adjustments based on the part size without tools. The redesigned chute also corrected the alignment, eliminating any jams. One of the guide plates was too short, allowing billets to hang up in the diverter and get stuck. They modified the size of the plate and welded it into the correct position, thus helping prevent billets from jamming in the chute. To make it easier to inspect the correct operation of the drive chain, the solid cover plate was replaced with a mesh screen. Afterwards, the cover plate was painted yellow for safety. A pneumatically actuated piston was utilized to move a billet into the cross roller. The team discovered that the pusher rod was misaligned and leaking air. They replaced the old unit with a new one and realigned it. A major issue was discovered when the team realized the rejection diverter could be mounted in the wrong position, upside down or backward, causing the diverter to miss a billet and jam. The team reworked the diverter and error-proofed it so that there is only one way to install it. The installation bolts were also replaced with T-handles so that it can be installed or removed without tools. On the reject conveyor, it was discovered that the electric drive motor was missing the entire cooling fan unit. This motor is mounted directly over the reject bin that contains hot billets, generating a lot of heat. The team replaced the entire motor unit and power cord. They also added visual temperature monitoring strips and a hot indicator, so anyone could quickly, visually see if the motor was in the correct operating temperature range. The team fabricated a heat shield to help reduce the heat from the billets going directly up to the motor and melting the power cord, possibly causing a short, electrocution, or fire. The bearing lubrication points on the reject conveyor were hard to reach, especially the one under the drive chain. The team made a lubrication manifold and fabricated tubing to all the lube points. Now all the bearings are lubricated from one convenient location.